Hello children, welcome to part 2 of some applications of trigonometry. As you know, in part 1, we have done how trigonometry has been used since ancient times. And we also did a number of examples in that part. Let us continue with this. Let us do some more examples. Children, let us do a question. A 1.2 meter tall girl spots a balloon moving with the wind in a horizontal line at a height of 88.2 meters from the ground. The angle of elevation of the balloon from the eyes of the girl at any instant is 60 degrees. After some time, the angle of elevation reduces to 30 degrees. Find the distance travelled by the balloon during the interval. So children, here we have drawn this figure to explain the position that is given in the question. This is the girl who has spotted the balloon. The first position is A and the second position is H. We have to find the distance travelled by the balloon, that is AH. The angle of elevation of the first spot is 60 degree and the angle of elevation of the second spot is 30 degree. Here children, these three lines are perpendicular to the ground, right? So they are all parallel. Similarly, this line AH is parallel to BF because they are horizontal lines, and again it is parallel to CE, which is the ground level. So we can say that this is a parallelogram, this is also a parallelogram, and this AHFG is a parallelogram. This explains a lot of things. So we get that BC will be equal to GD will be equal to FE, right? Because this is a parallelogram and opposite sides are equal. Similarly, this is a parallelogram and opposite sides are equal. So all of them are equal to 1.2 meters. Now in this case, I can say that AG is equal to HF. Now what is AG? AG will be equal to whole of this length AD minus GD. We know that AD, which is given that the height of the balloon above the ground level is 88.2 meters, and GD it is given to be 1.2 meters. So we get that 87 meters. So AG or HF, we have got it equal to be 87 meters. Now we want to find AH. We will find this AH with the help of trigonometry. Now AH is same as GF. So if I find GF, my purpose will be solved, AH will be found. So I basically want to find HF. So I basically want to find GF because that will give me the distance travelled by the balloon from A to H. Now this GF is not a side of any triangle, but I can find it from here. This GF is a part of this whole line BF, and from it if I cut this part BG, I will get GF. So if I want to find GF, I need BF and BG, because BF minus BG will give me this part GF, and GF is equal to AH, which I want to find. So what is the value of BF? I don't know. And what is the value of BG? Again, I don't know. So basically my purpose is to find these two lengths. One is BF, another is BG. Now BF, it is side of which right angle triangle? It is a side of triangle BHF. So let us try to find with the help of trigonometry in triangle BHF. I want to find BF. Do I know any length of this triangle? Yes, I know this part. I know that this is equal to 87 meters. Just here I have found that AG, which is equal to HF, it is equal to 87 meters. I know this part. I want to find this part. This is perpendicular and this is base. So tan 30 degree is equal to perpendicular upon base is equal to HF upon BF. Tan 30 is 1 by root 3. HF is 87 and this is BF. So BF is equal to 87 root 3 meters. So I have been able to find out BF, which was required here. Now I will find out BG. BG is a side of which right angle triangle? It is a side of triangle ABG. So in triangle ABG, now do I know any side of this triangle? Yes, I know AG, which is 87 meters. I have written it here. So I will use this side to find this side. This is perpendicular and this is base. So I will use again tangent, that is tan of 60 degree. So tan of 60 degree is equal to perpendicular upon base, which is equal to AG upon BG. So what is the value of tan 60? It is root 3. And AG I know 87 upon BG. I want to find BG. So I will get 87 upon root 3. This can be rationalized. The denominator can be rationalized. So I get into root 3 upon root 3. So I get 87 root 3 upon 3. So I cancel this. BG comes out to be equal to 29 root 3 meters. Now I had to find, again I am coming back to this, I had to find GF. So GF is equal to BF minus BG. BF we found out equal to 87 root 3 meters. BG is 29 root 3 meters. And on subtraction I get 58 root 3 meters. So this is the distance which is travelled by balloon from the first spot to the second spot. A straight highway leads to the foot of a tower. A man standing at the top of the tower observes a car at an angle of depression of 30 degree, which is approaching the foot of the tower with a uniform speed. 6 seconds later, the angle of depression of the car is found to be 60 degree. Find the time taken by the car to reach the foot of the tower from this point. So children, I have here drawn a figure according to the given question. Here I have taken AD as the tower and I suppose that the car is moving from point B to C and it is taking 6 seconds to reach from B to C. The angle of depression of the car at the point B is 30 degree and at the point C it is 60 degree. Now since this is a horizontal line and this is the ground level, they are parallel to each other. So because of parallel lines, these two are alternate interior angles. So this is also 30 degree. Similarly, since this is 60 degree, this is also 60 degree angle, right? So we have to find the time during which the car will travel from C to D. For this, I will have to find distance also. Now let us use trigonometry in both the right angled triangles. In triangle ACD, tangent 60 degree is equal to AD upon CD. So tan 60, the value of tan 60 is equal to root 3 AD upon CD. So I get root 3 CD is equal to AD. I have got AD in terms of CD. Now let me apply trigonometry in the other bigger triangle. In triangle ABD, tan 30 degree is equal to perpendicular upon base, which is AD upon BD. What is the value of tan 30 degree, children? It is 1 by root 3. So BD upon root 3 is equal to AD. Now here also we have found the value of AD in terms of CD and here we have found the value of AD in terms of BD. Now let us equate the value of AD. So from 1 and 2, we get root 3 CD is equal to BD upon root 3. So if I take root 3 to this side, I get square of root 3 CD is equal to BD. So I get 3 times CD is equal to BD. So BD is 3 times of CD. But BD comprises of two parts. One is BC and another is CD. So here we will write 3 times CD is equal to BC plus CD. CD is on this side also and on this side also. Let us take them together. 3 times CD minus CD is equal to BC. 3 times CD minus 1 times CD, it will give me 2 times CD is equal to BC. So here I have found a relation between BC and CD. Moreover, I know that the speed is uniform. It is not changing. So the speed for the interval B to C will be same as the speed for the interval C to D. So from B to C, speed is equal to distance upon time. That is, speed is unknown, distance is BC and time is, we have been given, it is 6 seconds. Now for the next travel, that is from C to D. Again, speed is equal to distance upon time. Speed remains same as this. So I will write BC upon 6. Distance is this much, CD. So I will write CD. Time we have to find. That is the thing that we have to find in this question. Now there is a relation between BC and CD. I will write BC is equal to 2 times CD. So CD gets cancelled with CD. I get time is equal to 6 upon 2, which is equal to 3 seconds. So the time taken by the car to move from C to D is 3 seconds. Children, the next question is the angles of elevation of the top of a tower from 2 points at a distance of 4 meters and 9 meters from the base of the tower and in the same straight line with it are complementary. Prove that the height of the tower is 6 meters. So children, here if we take AD as the tower, the 2 points C and B are at a distance of 4 meters and 9 meters respectively. And the angle of elevation from these 2 points are complementary. Now what are complementary angles? We have done in smaller classes that complementary angles are those angles whose sum is equal to 90 degree. So how can we suppose them? We can take them as, say if one angle is theta, I can take the other angle as 90 minus theta, right? So here I may take this as angle theta and this is angle 90 minus theta. So I will use trigonometry in the 2 right triangles that I can see here, that is triangle ACD and triangle ABD, and use it to find the height of the tower. Now first of all, let us look at the smaller triangle. In triangle ACD, tan theta is equal to perpendicular upon base, which is equal to AD upon CD. As you can see, this is the perpendicular and this is the base. I don't know the value of AD, of course, because I have to find it, but I know the value of CD, which is 4 meters, as it is given that the first point is at a distance of 4 meters from the base of the tower. So I get tan theta is equal to AD upon 4 meters. Now I'll apply trigonometry to the bigger triangle. In triangle ABD, again I am going to use tangent or tan. Tangent of 90 minus theta is equal to perpendicular upon base, which is equal to AD upon 9. So tangent of 90 minus theta is equal to AD upon 9. Now children, we have done in chapter number 8 that tangent of 90 minus theta is equal to cot theta. So cot theta is equal to AD upon 9. So this is the other result that I've got. So if I number this as statement number 1 and this is statement number 2, let us multiply statements 1 and 2. Multiply statement 1 with 2. So I get left hand side to be multiplied with left hand side. I get tan theta into cot theta is equal to AD upon 4 into this AD upon 9. Now we know that cot is inverse of tan theta. So this is AD square upon 36. So these will get cancelled. So I'll get 1 is equal to AD square upon 36 or 36 is equal to AD square. If I take square root on both sides, now I have to take only the positive square root because we are talking about height or length which cannot be negative. So I get it is equal to 6 meters. So the height of the tower is 6 meters. Let us do a few multiple choice questions and revise the chapter. Question number 1. Trigonometry is used for what kind of triangles? You have 3 options: right angle triangle, acute angle triangle, obtuse angle triangle. So what is the right answer? The right answer is A part, right angle triangle. Question number 2. A line drawn from the eye of an observer to the point in the object viewed by the observer is called, you have 4 options: straight line, horizontal line, line of sight and vertical line. So what is the right answer, children? Yes, the right answer is line of sight. Question number 3. If a kite is flying in the sky and at some point its angle of elevation is known, we also know the length of the string. Which trigonometric ratio will be used to find the height of the kite at that point? You have 4 options. First option, sin theta. Second option, cos theta. Third option, tan theta. And fourth option, cot theta. So children, can you tell me the answer? Yes, we will use sin theta, which is equal to perpendicular upon hypotenuse. Question number 4. If we are standing on the road and looking towards the top of a minar, the angle made by the line of sight with the horizontal line is called, you have 4 options again: A. Acute angle, B. Angle of elevation, C. Angle of depression and D. Right angle. So what is the right option? The right option is angle of elevation. So children, here we have done Class 10 Chapter 9, that is Applications of Trigonometry. I hope you have understood it and you also found it interesting how we can use mathematics in real life. That it is not only theoretical, it can also be applied. Practice a lot of more questions like this and stay healthy, stay safe, have a good day.